Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is unique ownership of memory. Before proceeding, make sure that you have already watched these other videos first. In the previous video, we illustrated the general form of a smart pointer this way, where the smart pointer variable, POSmart, is being given ownership over a dynamically allocated object. By ownership, we mean that now this smart pointer is responsible for deallocating that object's memory at the appropriate time. We don't need to program our own CR Smart class for implementing smart pointer behavior because the C++ language has already done that for us. Of course, the language programmed it in a generic way using templates so that we could own any kind of object, not only just these CR types. In the previous video, we showed how we might have implemented CR Smart if we had needed to reinvent C++ ourselves. In that example, our CR Smart had a very straightforward implementation, where that CR Smart object maintains exclusive ownership over that CR type memory allocation. In other words, that CR Smart object's decision about when to do the deallocating is not influenced by any other portion of the software. The C++ language provides a built-in class with this same type of behavior. It is called unique pointer. An uninitialized unique pointer is the same as one that was initialized to a null pointer value. In either case, casting the smart pointer into a Boolean will yield a value of false. You could reuse the unique pointer variable, causing it to start owning some new memory allocation. To do so, call its reset function, passing that new memory allocation to it. Because a unique pointer can only own one memory allocation at a time, the unique pointer will first deallocate whatever memory allocation it had already been owning, and then it will start owning that new memory allocation. The reset function could also have been used to put the unique pointer back into its uninitialized state by passing a null pointer. Not only does the C++ language provide move semantics for its implementation of a unique pointer, the language actually requires you to use them whenever you want a construction or an assignment. It wouldn't make sense to copy construct or copy assign a unique pointer, since it's supposed to maintain unique ownership, not some copy of ownership. If you tried to do copy construction or copy assignment, then you'd receive an error. Whenever an object is passed by value into a function, a copy constructor or move constructor is always used. Again, a unique pointer requires you to use move semantics. This means that ownership of the memory allocation is transferred into the formal parameter, into the function. After the function is completed, the caller's smart pointer variable will be back in its uninitialized state. By the way, copy construction and move construction is also used when an object is returned by value. This means that when returning a unique pointer, that function would be returning ownership out to the function caller. If you want this client code to give the function access to the memory allocation without transferring ownership to the function, then pass by reference instead. A unique pointer can be a constant variable, but then it cannot participate in any move construction nor move assignment. So, as we just saw before, that means a constant unique pointer cannot be passed into nor out from a function. A constant's underlying data could still be modified.